Okay, now when we look at this example, we recognize that we have a function in terms of u, an f function in terms of u, and then it defines u, and then it's asking me to take the derivative. We should recognize that this is the composition of functions. So really what this is f of g of x is going to be x squared minus 1 cubed plus 2 times x squared minus 1. Okay, but it wants me to take the derivative. Well, the derivative of that function is going to be f prime of g of x times the derivative of the inside, which is g prime of x. Well, I can just go ahead and find g prime of x. That's going to be 2x. And f prime of u is going to be 3u squared plus 2. So it's going to be 3, and then u is x squared minus 1 squared plus 2 times the derivative of the inside, which is 2x. And if you take the derivative of this, you're going to get the same result. This, if I had gone ahead and done the substitution in first, that's going to be 3x squared minus 1 quantity squared plus 2 times 2x. And you can see that your end result is going to be the same. Because I forgot, I was wondering why it wasn't the same. Forgot the derivative chain rule, typical chain rule, derivative of the inside was 2x, and then, thank you, plus (4x), which that, in this case, does remultiply to be out to be the same. All right, next example. Okay, and I want it evaluated at t equals 3. Well, I'm going to do dx dt. The derivative with respect to t is just going to be 4t, and dy dt is 6. So I'm taking the derivative. I can, whatever letter is here on the bottom is the variable that you're taking the derivative of. Okay, and it wants dy dx. Well, if I just look at this versus this, dy over dt over dx dt is going to reduce, do a keep change flip, to dy over dt. So if I take the 6 over 4t, I'm going to get, that's just going to be your dy dt over your dx dt. That reduces to 3 over 2t. Again, you don't have to reduce in calculus, but it helps if you do. And I want at a t equals 3, that's going to be 3 over 6, so it's going to be 1/2. All right, go ahead and pause here and take a moment and do that problem on your own. It's the same concept, they just gave you slightly different information. So be careful about that. So dy over dt, that means it had to be equal to dy over dx over dx over dt. Because if I do a keep, so dy dt, change that division to multiplication, and then dt over dx, then my dt's will cancel and give me dy. Sorry, didn't do that one right. That's dy over dt over dx over dt. So that's going to be times dt over dx. So my dt's cancel, giving me dy dx, which is not correct. Let me rethink this. I want dy dt over, let's say, over dx dt is going to give me dy over dx, because we've just proven that. So I know that dy over dt is going to be equal to, sorry about the mistake earlier, dy over dx times dx over dt. So dy dt is going to be equal to dy over dx, which is 3, times dx over dt, which is going to be 4. So my answer is going to be 12. All right. This example is going to be the power rule with a chain rule. So this is going to be 5 e to the negative t plus e to the t times the derivative of the inside, which e to the anything is e to the anything, times the derivative of the inside, so that's going to be a negative out front. And then derivative of e to the t is just e to the t. And you're done with that.